Hi, everybody. It's Professor Mitchell continuing with Chapter 4. Today, we're going to look at Section 4.2 on using the simplex method to solve maximum problems. All right, so the only objective in this section is using the simplex method for problems in standard form. All right, so here we'll go over the steps for how to use the simplex method to solve a maximum problem. First, we'll introduce slack variables and state the problem in terms of a system of linear equations like we talked about in the last section. Then we'll construct the simplex tableau corresponding to the system, which we also went over in the last section. Okay, now we get to the part that we did not go over in the last section. So to begin, we're going to look at the left part of the bottom row, everything except for the very last number, and see if there are any negative entries. If there aren't any, then the solution corresponding to the tableau yields a maximum and the problem is solved. So this usually will not happen in the very first step. If the left part of the bottom row does contain negative entries, we're going to construct a new simplex tableau by pivoting. So I'm going to now explain to you how to choose the pivot element. Choose the pivot column by inspecting the entries of the last row of the current tableau, excluding the right-hand entry. The pivot column is the one containing the most negative of these entries. So look for the most negative number in the bottom row, and that's going to be your pivot column. Next, we'll choose the pivot element in that column by computing ratios associated with the positive entries of the pivot column. The pivot element is the one corresponding to the smallest non-negative ratio. Now, they have not completely explained this. It will make perfect sense when we do an example. Basically, this ratio is the number in the right column divided by the number in the pivot column. All right, so you're looking for the least of those ratios. Then we'll construct the new simplex tableau by pivoting around the selected element. So then we return to step 3. Steps 3 and 4 are repeated as many times as necessary to find a maximum. In other words, once you have your new tableau, look in the bottom row for a negative entry. If there isn't one, you're done. If there is one, choose the most negative one, and then look at your ratios to see where to pivot next. All right, so as an example, we're going to use the chairs and sofas problem from chapter 3, which is to maximize 80x plus 70y, subject to those same constraints. Now, we did set up a simplex tableau for this problem in the last section. And the way that worked is first we introduced our slack variables. And then we get our corresponding linear system, which you see here. Okay, and then we set up the initial simplex tableau, which looks like this. Now at this point, I am going to switch over to my tablet to complete the problem. Okay, so the first thing I better do is erase these little scribbles at the bottom here. As I was talking to you just now, my cat was walking on the tablet. All right. Okay, so here we go. I'm looking in the bottom row for negative entries. Specifically, you're looking here. And there are some negative entries there, and the most negative of those entries is right here. So my pivot column, that's my pivot column. And now I'm going to look at my ratios. So the way that you do the ratios, and I just realized I haven't quite left myself enough room here. Let me scoot this over just a little bit. Okay. is you look at the number in the right-hand column and then divide by the number in the pivot column. So in this row, that number is a 6. So that ratio is 16. In this row, it's 18 divided by 1, which is 18. And in this row, it's 72 divided by 2, which is 36. So the least of those ratios is the 16, which means I am going to pivot about this element. Okay. All right. So let's see, it's going to be a bit of a tight squeeze. First thing I'm going to do is multiply that whole entire row by 1/6. And I'll talk in just a minute about, well, I mean, the variables that you see up top are just labeling the columns, right? These variables here, I will explain in just a minute what those are doing. Actually, I'll explain it right now. So those are my group 2 variables. If I were to read the solution off the tableau that I have, those are the variables that correspond with columns that look like an identity matrix, right? So if I was going to read a column or read a solution off this, I would cover up the X and the Y column, and then my solution would be U equals 96, V equals 18, W equals 72, and M equals 0. Okay. All right. So after I pivot, one of those group 2 variables is going to change. So we'll see what happens there in just a second. All right, multiplying row 1 by 1/6. I get 1. 3 divided by 6 is 1/2. 1 divided by 6 is 1/6. 0, 0, 0. And then 96 divided by 6 is 16. Okay. All right, now at the same time, I am going to get zeros in the other 3 rows. Hopefully this won't be too confusing. Back in chapter 2, I always used to do this as its own step, and then I would do all of those other operations in the next step. I'm going to try to do it all in one step now that we are all presumably experts at doing matrix operations. Okay, well, fortunately, we start with an easy one, row 2. We're just going to change that by adding -1 times row 1. In other words, row 2 minus row 1. Now understand, I mean this row 2 and this row 1. Okay. So 1 minus 1 is 0. That was the whole point. 1 minus 1/2 is 1/2. 0 minus 1/6 is -1/6. 1 minus 0 is 1. 0 minus 0 is 0. 0 minus 0 is 0. And 18 minus 16 is 2. Okay. So that's our new and improved row 2. For row 3, I'm going to change row 3 by adding -2 times row 1. So here we go. 2 plus -2 times 1 is 0. That was the whole point. 6 plus -2 times 1/2 is 6 plus -1, which is 5. 0 plus -2 times 1/6 is -1/3. 0 plus -2 times 0 is 0. 1 plus -2 times 0 is 1. 0 plus -2 times 0 is 0. And 72 plus -2 times 16 is 72 plus -32, which is 40. All right, and that brings us to row 4. So for row 4, we need to do row 4 plus 80 times row 1. All right, so here we go. Negative 80 plus 80 times 1 is 0. That was the whole point. Negative 70 plus 80 times 1/2 is negative 70 plus 40, which is negative 30. 0 plus 80 times 1/6 is 80 over 6, which is 40 over 3. 0 plus 80 times 0 is 0. 0 plus 80 times 0 is 0. 1 plus 80 times 0 is 1. And 0 plus 80 times 16, 80 times 16 is 1,280. Okay, so the columns still represent the same variables. However, we have a new set of group 2 variables. The columns that do not look like an identity matrix are Y and U. So if I imagine covering those up, I would be left with X equals 16, V equals 2, W equals 40, and M equals 1,280. Okay. All right. And Y and U are both 0. Okay, so I think we got this far in the last section, and we said that this tableau corresponds to manufacturing 16 chairs and 0 sofas, which I remember from chapter 3, the point 16, 0 was one of the vertices of the feasible set, but it was not the one that gave the maximum solution. Okay, so now we look to see if we're done. I mean, based on what I just said, it sounds like we're not done. All right. But normally you're not going to know that, right? Because there won't be a problem that you've done before. So if you look in the bottom row, I see there is still a negative entry, which confirms that we're not done. So now I have to look at my ratios again. And once again, I have not left enough room. So let me scoot this over. Okay, that should be all right. Okay, so first we would have 16 divided by 1/2. 16 divided by 1/2 is 32. 2 divided by 1/2 is 4. And 40 divided by 5 is 8. So the smallest one of those ratios is the 4, which means the next place I'm going to pivot is going to be about this 1/2. All right, so we're ready to do our next pivot. So the first thing we have to do is multiply row 2 by 2 in order to change that 1/2 into a 1. Okay, so that's going to look like 0, 1. 2 times negative 1/6 is negative 1/3. 2 times 1 is 2. 2 times 0 is 0. 2 times 0 is 0. Whoops. I thought this matrix looked a little too small. Forgot to leave a space for the right-hand column. Okay, and then 2 times 2 is 4. All right, so now we have to create zeros in all of those other spots in the second column, starting with row 1. We're going to change row 1 by adding negative 1/2 times row 2, talking about the new row 2. Okay, so let's see. 1 plus negative 1/2 times 0 is 1. 1/2 plus negative 1/2 times 1 is 0. That was the whole point. Negative 1/6 plus negative 1/2 times negative 1/3 is negative 1/6 plus 1/6. Whoops. Okay. I should be looking at this row. All right. 1/6 plus negative 1/2 times negative 1/3 is 1/6 plus 1/6, which is 1/3. Okay. So let me say to you something that I was thinking about just a minute ago. I recommend actually breaking this into more steps than I'm showing. For purposes of the video, the video gets to be really long if I break it into too many steps. So, you can break the matrix operations up, just as much as we did in chapter 2. All right. And in fact, I would probably recommend that. Okay. So back to this, row 1 plus negative 1/2 times row 2. So 0 plus negative 1/2 times 2 is negative 1. 0 plus negative 1/2 times 0 is 0. 0 plus negative 1/2 times 0 is 0. And 16 plus negative 1/2 times 4 is 16 minus 2, which is 14. All right. On to row 3. In row 3, we have to get rid of a 5. So we're going to change row 3 by adding negative 5 times row 2. Okay. So now we're looking here and here. All right, so 0 plus negative 5 times 0 is 0. 5 plus negative 5 times 1 is 0. That was the whole point. Okay, negative 1/3 plus negative 5 times negative 1/3 is negative 1/3 plus 5/3, which is 4/3. 0 plus negative 5 times 2 is negative 10. 1 plus negative 5 times 0 is 1. 0 plus negative 5 times 0 is 0. And 40 plus negative 5 times 4 is 40 plus negative 20, which is 20. All right, one more row to go, and that's row 4. We need to get rid of a negative 30, so we're going to do row 4 plus 30 times row 2. Okay, so now we're not looking here anymore. We are looking here. All right, here we go. 0 plus 30 times 0 is 0. Negative 30 plus 30 times 1 is 0. That was the whole point. 40 over 3 plus 30 times negative 1/3 is 40 over 3 minus 30 over 3, which is 10/3. 0 plus 30 times 2 is 60. 0 plus 30 times 0 is 0. 1 plus 30 times 0 is 1. And 1,280 plus 30 times 4 is 1,280 plus 120, which is 1,400. All right, and that's good news because notice we don't have any more negative numbers in the bottom row. So before I read off the solution, let me put in the new set of group 2 variables. I don't really have, okay. So the group 1 variables are U and V. Those are the 2 columns that don't look like an identity matrix. So if you ignore those columns and look at what's left, you have X, you have Y, you have W, and you have M. All right, so let me just make a little bit of room down here. This simplex tableau corresponds to U and V equaling 0, X equals 14, Y equals 4, W equals 20, and M equals 1400. So that agrees with the solution that we found in chapter 3. In order to maximize profit on the manufacture of chairs and sofas, you should manufacture 14 chairs and 4 sofas for a maximum profit of $1,400. All right, back to the presentation. Okay, we can skip through this. This looks like what we did. All right, there we go. Okay, so it's been a few sections now since we've had an audience participation problem. When I teach this class face-to-face, sometimes I have just used this as another example, but I want to offer this up in case you would like to do it for the discussion if you're a student in my class. A builder has $6 million and 12 acres of land on which to build cottages, ranch houses, and McMansions. Each cottage requires 1/4 of an acre of land and $100,000 to build and yields a profit of $6,000. Each ranch house requires 1/2 an acre of land and $400,000 to build and yields a profit of $13,000. Each McMansion requires 1 acre of land and $200,000 to build and yields a profit of $14,000. How many houses of each type should he build in order to maximize his profit? All right, so the simplex method entails pivoting around entries in the simplex tableau until the bottom row contains no negative entries except perhaps the entry in the last column. And that won't even happen too often. Well, maybe in the next section it will. The solution can be read off the final tableau by letting the variables heading columns with 0 entries in every row except the ith row take on the value in the ith row of the rightmost column and setting the other variables equal to 0. In other words, just look at those identity matrix columns, match those up with the numbers in the right-hand column. The columns that don't look like an identity matrix, you set those variables equal to 0. And that's going to do it for section 4.2. We'll see you next time.